Hello there. In this video, we'll be learning about the indeterminate form infinity over infinity. So first, recall that in the previous video, we had this example. Observe that if we directly substitute infinity in this function, we'll obtain this. Simplifying, this is equal to infinity over infinity. This is an indeterminate since we don't really know what happens when we divide infinity to another infinity. So how do we do this? Well, what we can do here is split this fraction into 2. That is, we'll have 2x over 5x plus 4 over 5x. And in here we can divide this. So that is, we'll divide the two x's out here. Take note that we can do that since as x approaches positive infinity, x is not equal to 0. So technically we can really do that one. And so we'll be left with the limit as x approaches positive infinity of 2 over 5 plus 4 over 5x. Now for this example, if we plug in infinity, observe here that this one out here is of the form constant over infinity. And we know that when a limit approaches that one, that means that the limit approaches 0. So we'll only be left with 2 over 5, and so the answer for this limit is equal to 2 over 5. This out here is the final answer. So this is how to answer the exercise in the previous video. But take note that we can't really do this always. We can't really just split this fraction into 2, since sometimes if we have a polynomial already, say x raised to 4 plus x cubed plus 2 the numerator we have x cubed plus 2 plus x like that. We can't really just divide this easily like in here. So what do we do? Well, let's try to have this example, and let's use this example to show the trick that we can use when dealing with infinity over infinity limits. So for our first example, we have the limit as x approaches negative infinity of 9x minus 1 over 3x plus 4. Before I solve this, feel free to pause the video so that you may try this one first on your own. Okay, good. So let's start. Observe that if we plug in negative infinity out here, the outcome would simplify to infinity over infinity, which we know to be an indeterminate, as mentioned a while ago. And so, how do we do this? Well, let's first copy this out here. There. Well, the trick that we can use here is we can divide, or rather we can multiply the numerator and the denominator by 1 over x. And we'll see later why we do this. So multiplying 1 over x in the numerator and in the denominator, take note that we can do this since as x approaches negative infinity, x is not equal to 0, so these values won't be undefined. There. So by doing that, the limit or the function becomes 9 minus 1 over x over 3 plus 4 over x. And observe what happens here when we plug in negative infinity in this function. We'll have 9 minus 1 over negative infinity all over 3 plus 4 over negative infinity. As we know, when the limit approaches constant over infinity, the outcome is just 0. Therefore, the limit for this one simplifies to 9 over 3, or when simplified is equal to 3. This out here is the final answer. So as you can see, we did this so that we can convert the numerator and the denominator out here with a term of this form, since we know that when we plug in infinity out here, this just becomes 0. So it's easy to cancel out. So we'll try to examine more examples similar to this one. Let's have this second example. By the way, apologies for the loud noise. I don't know if you can hear it. I hope not, but yeah, continuing. We have the limit as x approaches positive infinity of x squared minus x plus 2 all over 4x cubed plus x squared minus 1. Before we start, again, feel free to pause the video so that you may try this one first on your own. Okay, good. So let's start. Again, observe that when we plug in positive infinity out here, the outcome would be infinity over infinity, which is an indeterminate. So let's copy this one. And as in a while ago, we know that a trick here is to divide this by 1 over x. But this time, our exponent or the degree in the numerator is 2. For the denominator, the degree is 3. So if we just divide the numerator by x and the denominator by x, we'll be left with x minus 1 plus 2 over x all over 4 x squared plus x minus 1 over x. So we'll still have this. So when we plug in infinity, the outcome would still be infinity over infinity. So that really, this idea doesn't really work. But the technique here is quite similar to this. But what you need to remember is that what we divide is, instead of 1 over x, we divide it by 1 over x raised to the highest exponent in either the numerator or the denominator. In this case, the highest exponent is 3. So what we multiply here is 1 over x cubed. And you'll see that if we multiply this to the numerator and the denominator, we'll have the limit as x approaches positive infinity of 1 over x minus 1 over x squared plus 2 over x cubed all over 4 plus 1 over x minus 1 over x cubed. And here, when we plug in infinity, observe that 1 over x just becomes 0, negative 1 over x squared also becomes 0, so is 2 over x cubed rather. Then the 1 over x in the denominator becomes 0, and so is 1 over x cubed. So we'll only have here 0 over 4, or when simplified is just 0. This out here is the final answer. So as you can see, although it might seem scary at first since we are dealing with infinite values, just by this simple trick out here, the limit simplifies to just 0. So I hope you got that one correctly. And now let's move on to the third and final example. So we have here the limit as x approaches positive infinity of the square root of x squared plus 2 all over x minus 3. Again, feel free to pause the video so that you may try to work on this first on your own. Okay, good. So let's start. Again, when we plug in positive infinity in this function, we'll have infinity over infinity, which is an indeterminate. So to solve this, first take note that if we try to find the square root of x squared, this is equal to not only x but rather absolute value of x, or that is, we have x if x is greater than or equal to 0 or non-negative, or negative x if x is negative or x is less than 0. So we'll use this idea in answering this problem. So I just copied it out here. So in here, what do we need to multiply? Again, we base it on the highest exponent present. But unfortunately, we have a radical out here. So let's try to focus first on the radical. What can we do to eliminate this one out here? Well, we can multiply 1 over square root of x squared all over 1 over square root of x squared. Since again, when we multiply radicals, so for instance, in this case, we have square root plus 2 over square root of x squared. This just simplifies to the square root of x squared plus 2 over x squared. So we can divide this to here and here. But in the denominator, we don't have any radicals. So what is the value of 1 over square root of x squared out here? Well, based on our note, since we are dealing with values or x values as it approaches positive infinity, that means that x is positive, or we are dealing with this case out here. So the 1 over square root of x squared out here just becomes x, this one, since again it is positive. There. And so using this idea, we can now multiply these factors into this function. So we'll have this. So we have the limit as x approaches positive infinity of the square root of 1 plus 2 over x squared all over 1 minus 3 over x. And again, as x approaches positive infinity, 2 over x squared and 3 over x just becomes 0. Therefore, we'll be left with square root of 1 over 1, or simply just 1. This out here is the final answer for this third example. So yeah, I hope you got that one correctly. If not, I hope you understand the process in solving this example as well as the first 2 examples in this video. To formally end this, here are 2 exercises that you can work on. So first we have the limit as x approaches infinity of x raised to 100 plus x raised to 10 plus 10 all over 9x raised to 99 minus x raised to 9 plus 9. So it might seem overwhelming and scary at first, but the key here is to just apply the same concept that we had earlier, especially in example number 2. For the second one, we have the limit as x approaches negative infinity of 4x minus 17 all over the square root of 4x squared plus 3. In here, to solve this, the idea is to apply what we did in the third example. But in this case, we have negative infinity. So this means that in the square root of x squared, this is equal to absolute value of x. Then we have x if x is greater than or equal to 0, or negative x if x is less than 0. So technically, when we are dealing with values of x as it approaches negative infinity, we're dealing with negative values. So what we use in this case is this one. So yeah, I hope you enjoyed this one and learned a lot from this one. Feel free to comment down below your solutions and answers to these exercises if you have one, or if not, just comment whatever you want. So yeah, that's it, and that is all for this video.